Assalamualaikum warahmatullahi wabarakatuh. My name is Intaras Nafitri Wijayamulyono. Today I will explain about the experiment 3, which is the determination of the jet velocity and the nozzle efficiency. So the objectives for this experiment is to find the efficiency values of different types of the nozzle.
Okay, next we proceed to the procedure. So this is the diagram for this nozzle performance test unit. So for this experiment, we have to wait for this, and I will show the procedure for this test. So firstly, the air compress, it will come through from the air inlet and it will pass through the control valve. After that, it will move up until here, and then it will go to the inlet pressure. So it will go to the two parts. So it's to the diverter valve and then the inlet pressure. So inlet pressure, it will read the pressure, which is the pressure 1, and then it will go to the, and then for the second part, it will go to the diverter valve, and then it will move to the right, and then it will read the temperature, which is a thermometer, which is at the T1, and then it will go to the nozzle. Here, this is the nozzle. So at the nozzle, it has the, before you attach the nozzle, it has the hose retaining the nut. So you have to insert the nozzle. So when you do the for the nozzle 1, you have to put it on the hose retaining the nut. So you have to end tight, don't attach too tight. And then before that, you have to calibrate the heat, and then because every size of the nozzle, you have to do the calibration. So before you do the calibration, you have to make sure the chamber pressure control valve is open, which is the before you do the calibration. So next, you do the calibration. You have to read the disc reading. The reading at the disc, we have to set to 0. So it has to change to 0, and then at the volt, we have to make sure it's 0.5. So if the volt more or less than 0.5, we cannot get the exactly result. And then after, you have to set up the calibration, and you have to put the nozzle that attached at the hose into the chamber. So this is the chamber, so you have to attach this hose into the chamber. And then as you attach the nozzle at the hose, you have to attach the hose to the chamber and tight, not very tight. So, and then the pressure will flow through the hose and then through the impact head. So the pressure will flow through the nozzle and impact head. After that, it will flow to the chamber. Then the pressure will show the readings at the flow meter. So it will this one, it will move up. And then when you take the reading, when you want to take the reading, so you have to take the reading top of this part. So you have to make sure that your arc is perpendicular to the reading. So when you take the reading, you don't have to worry about the parallax error. And then when you want to make the reading at the flow meter rate, you have to open the pressure valve, and then you take the reading. As I said just now, you have to take the reading at the top, and then like this. And then you have to, and then the pressure will come out from this part, will release. And then when the experiment starts, when the volt height, you have to the micrometer not it become more closer, and then you have to adjust the micrometer adjustment downward to and then at the same time, you have to make sure the volt is 0.5 reading. So when you want to move the micrometer adjustment, you have to move it clockwise to bring it upward. And then you let the as you need to in 1 minute, and then take the reading, which is the temperature 1, cantilever, and the flow rate T1 per meter, and the cantilever. And then when the test is undergoing, when you want to do the test 2, which is the P2, P2 is 100 meters. So which means when you have to make sure that the inlet pressure is constant. And then you have to repeat the test at other chamber pressure, which is 1 kilopascal increment. So you have to repeat all the experiment with the other nozzle.
Okay, so this is the table and the graph for the 1, 2, and 5. So graph the and graph table for nozzle 4, nozzle 5, and this is the graph for the nozzle 5. So we proceed to do the table for this experiment. So let's do it. Okay, now I will show you how to do the graph for nozzle efficiency against the pressure ratio, and then the MS flow rate versus the against the pressure ratio.
Okay, for the conclusion of this experiment, in conclusion, the objective of this experiment are successfully studied and determined throughout the experiment, and predicated on the experiment, efficiency of the jet nozzle increased with the velocity, and the velocity increased as the smaller the nozzle diameter. A convergent divergent nozzle is a supersonic nozzle where the supersonic velocities are attained. It has a divergent portion downstream of the contracting section, meanwhile a convergent nozzle is a nozzle that starts big and gets smaller decrease in a cross-section area. These nozzles are used to convert pressure energy to kinetic energy to produce thrust. Depending on the exit match number, a suitable nozzle is designed. The convergent nozzle is used for subsonic flow and supersonic flow. A convergent divergent CD nozzle is employed. Next, we go to the application. So first, for the first application of this nozzle, which is the water jet cutter. This application also known as a water jet or water jet, and industrial tool capable of cutting a wide variety of material using a high pressure jet of water or a mixture of water and abrasive substance. And next, for the next application is that with propulsion. The exhaust gas, which is the bypass in the two movements, are expanded and accelerated through the nozzle, accelerating the flow, reducing the stream static pressure, and providing propulsive force. And next, for the recommendation, in this experiment, we are determining the jet velocity and nozzle efficiency. So we are trying to find the correlation between the two variables. To improve the experiment, we need to have the ideal nozzle and nozzle efficiency. The ideal characteristic of the nozzle efficiency will be visible, meaning that it does not have heat transfer, frictional effect, shocks, and many more. This condition is called isentropic. So the first one is by conducting atmospheric low pressure laboratory flow test, evaluate the overall effect of the nozzle length and approach and exit shape of the nozzle efficiency, and flow characteristics, and establish the most promising combination of these factors for further laboratory and field research design of nozzle. And secondly, we have to perform the high pressure laboratory flow test against varying back pressure in a particular test chamber to compare the performance, velocity distribution, and impact characteristic of the nozzle with the commercially available characteristic of the nozzle. And lastly, we can conduct a field test to assess the effect of the new nozzle on the rate of jet velocity and nozzle efficiency. So that's all for this experiment. From me, thank you.